Hello friends, my name is Chinmay Deshpande. In this video lecture, we are going to discuss about a topic from reactive power control. The name of the topic is relation between receiving end voltage and net reactive power. Let us consider the following diagram. Here, this V1 is nothing but sending end voltage, V2 is receiving end voltage, PS plus JQS is active component of the power, this is supply side, and reactive component of the power, that is from supply side. P load plus JQ load is nothing but this is load active component power and this is load reactive component power. JX is nothing but reactance of the line. Now, the sending end apparent power, we can write it as SS or we can represent it as S1 will be equal to V1 into IS star, that is complex conjugate of the current. Now, how we can write a formula for the current? This is your current IS, I can say. So, how you can write current? That IS will be equal to V1. Now, this V1 is at an angle delta and this V2 will be at an angle 0. So, V1 at an angle delta minus V2 at an angle 0 divided by the total reactance in between these two, that is Jx. So this is your expression for Is, or you can say this is expression for I1. So we can write this V1 here, this V1 as it is here. Now here this is your load angle delta. Now V1 at an angle delta minus V2 at an angle 0 upon Jx star, this whatever formula we have shown in this bracket, it is nothing but formula of current Is. Now SS will be equal to V1 at an angle 0. Now what I will do, whatever this term 1 upon J, I will make it in an angle. So it is 1 at an angle minus 90 degree. So therefore V1, this V1 at an angle delta minus 90 degree. Here as 1 by J equal to 1 at an angle minus 90 degree. So we will get angle as V1 at an angle delta minus 90 degree upon X minus V2 at an angle minus 90 upon X. This complex conjugate is as it is. Now if I want to remove this complex conjugate, then what we have to do? Just we have to change the direction, or we can say change this angle sign. Don't change this magnitude. So it will be what? SS equal to V1 at an angle delta. This V1 will be as it is. Here instead of delta minus 90, we have to write 90 minus delta upon X. Similarly, V2 at an angle minus 90 degree, for that case we can write V2 at an angle 90 degree upon X. So if I multiply this term, that is V1 at an angle delta inside, then we will get V1 into V1 is V1 square upon X. Now we have to add these angles. So delta plus 90 degree minus delta. So what we will get? We will get here as a 90 degree. Similarly, if we multiply this term V1 at an angle delta inside, then what we will get? Here we will get V1 V2 upon X, this delta and this 90 will be added. So mark this as the expression number 1. This is what is sending end apparent power, which is denoted by equation number 1. Now here we will be able to find it out, the active component or active power component. So what we have to take? We have to take a real part, that is we have to take a cos angle. So from the previous one, if we take a cos of angle, what we will get? V1 square upon X cos of 90 degree minus V1 V2 upon X cos of 90 plus delta. Now we know that what is cos 90? It will be 0. And cos of 90 plus delta, it will be equal to minus sin delta. So we will get expression for the active power. That expression is nothing but what? V1 V2 upon X into sin delta. Take this as a equation number 2. Similarly, we can find it out the reactive component. What we have to take here? We have to take an imaginary part, that is sin angle of equation number 1. So we will get QS equal to V1 square upon X sin 90 minus V1 V2 upon X sin 90 plus delta. Now we know that sin 0 0 and sin 90 is 1, so we will get V1 square upon X, and here sin of 90 plus theta or 90 plus delta will be equal to cos delta. So we can write it as minus V1 V2 upon X into cos delta. Now can I take V1 common? Yes. So V1 and X we will take common, we will get V1 upon X into bracket V1 minus V2 into cos delta. Mark these as a equation number 3. Now here from the previous expression I am going to write an expression for V2 cos delta. So what it will be? It will be V1 minus X upon V1 into QS. Mark these as a equation number 4. Now if we have a small value of the load angle delta, let's say if we have small value delta equal to, let's say 0.01 or it is equal to 0.001, I can say it is nearly equal to 0. So we know that when we put delta equal to 0 and we have a cos delta, then how we can write cos delta or cos 0? Here it is nothing but what? Here we will write it as a 1. So therefore we will get the expression as cos delta, that is cos 0 equal to 1. So we will have V2 equal to V1 minus X upon V1 into QS. This is treated as a equation number 5. Now this is very important equation which will be used for analysis of various compensating devices. Now here the net reactive power in the transmission line, it is represented by QS. So this QS is the net reactive power in the transmission line. Now from this V2 equal to V1 minus X upon V1 into QS, we can write a conclusion. We have 3 ways to control the receiving end voltage. First is nothing but what? We have to change the source voltage value, that is V1. But obvious it is not possible. It requires internal voltage control, which is highly impossible. Second is nothing but we have to change the reactance of the transmission line, so that we are going to change the reactance with the help of series compensation. And next is nothing but change the net reactive power to be supplied by the system. We can do it with the help of implementation of shunt compensation. So this is what is about relation between receiving end voltage and net reactive power. Thank you. If you have any doubts, please feel free to ask.